Hey everyone, so this is our video on sex-linked inheritance, and by the end of this video you should be able to predict offspring ratios based on a variety of inheritance patterns, and we are specifically looking at sex-linked traits in this lesson. So this is a form of inheritance where the gene or allele for the characteristic that you're looking at is on the X chromosome. Okay. Diseases such as color blindness and hemophilia are inherited this way, and they are more common in males than females because remember, males have only one X. So if that X is the form that expresses these diseases, that male is going to have that disease. So that's why we look at X-linked. So a lot of times people, sex-linked inheritance, but you can say X-linked because it's specifically on that X. Remember that females are XX and males are XY. So that's why they have half the chance to express this than a female. So for hemophilia, which when we look at that, it is blood clotting. So hemophilia is when your blood does not clot the way it's supposed to, which is why cuts can be very, very dangerous for a hemophiliac because they could bleed out very easily. So a capital H is the allele for normal blood clotting, whereas the lowercase h is the allele for hemophilia, which means that this is a recessive disorder. Okay. So a normal female would have two X's where they have capital H's, and this is how we write them for sex-linked traits. You put the sex chromosome, the X or Y, and then you have to put the letter up as like an exponent. The genotype for a hemophiliac female, which is far less likely, still possible, but less likely, are the X's with two lowercase h's. If a female has one capital H and one lowercase h, that means that the female is a carrier of hemophilia. So she will actually have the normal blood clotting ability. She will not express this gene, but she can pass it on to her offspring because she has it. And then a normal male would have the X with a capital H, and the hemophiliac male will have an X with a lowercase h. So let's make sure we do understand what it means to be a carrier, because a carrier means that, like we said earlier, will express as a normal functioning individual or organism, but still can pass that gene on to their offspring. So carriers are female only because they have two X chromosomes. Having two X's means that if they have one dominant, then they're going to express the dominant, but they could still have that allele as a heterozygous female. The carrier female appears normal, but has one allele that is affected by whatever disease they're looking at. So the lowercase h in hemophilia. So mom can pass that affected allele onto her children. And this is how you can have an affected male from two phenotypically normal parents. Because the males only get one X. So it would get the mother's X. And if it happens to be that lowercase h, that offspring would have hemophilia. So a man with normal blood clotting ability, as you can see his expression there, marries a woman who is hemophiliac. So she only has lowercase h's, and they are having a baby boy. What is a possibility that he will have hemophilia? So here's how you write these, because usually you only have one letter up there. You have to split these up as X and X or X and Y with the trait written as the exponent. So we've got the male on top and the female on the side. And then you just fill this in like a normal block. Remember, since they know they are having a boy, so let me make sure you realize they said baby boy, which means we have to look at the ones with the Y's. We don't care about these because those are the girls. We are looking specifically at the boys. So when you look at these, you can see that the The possibility of the boy having hemophilia is 100% because they have no chance at an uppercase X, since that has to come from the mom. All right, so we're going to set this one up, but I want you to do this example. So a normal woman marries a hemophiliac man. Before they conceive, she wants to know if there is a possibility that any of their children will have this disease. So if we set this box up, I want you to go ahead, pause the video, fill out your Punnett square, and give me the percentage on if children will have hemophilia. So now let's move into color blindness. So a capital C is normal vision, lowercase c is color blindness. So remember that means recessive as well. And we've got our genotypes here. So I'll just kind of start these. Remember, all uppercase means normal. One uppercase means you're still going to look normal, but you have a carrier as a female. And then you can see the genotypes for your males here. So pause this if you need to write these down. And a man with normal vision, right, and a colorblind woman have children. Possible genotypes and phenotypes for their children are what? So let's set up the outside. I want you to go ahead and try to fill in this block. So pause the video. And now let's look at this example. So when we fill this in, we can tell that the genotypes here, we're going to have half colorblind carriers for female and half colorblind males. Okay. So we have, and you can see that here, which means your males, all the males that would come out of this relationship would be colorblind. But the females would have the gene, the trait, just not express it. Okay, so you would have 2 carrier females and 2 blind males out of this Punnett square. So a carrier female and a normal vision male have children. What percentage chance does the couple have of producing a male baby who is normal visioned? So we have this here. I want you to pause the video and try this example. All right, guys, so this is the end of our video, and hopefully now you understand sex-linked inheritance.